Okay, I think I'm live now. Thank you very much for that talk, Americ and other authors. Same format as before. If you could ask your questions inside the page chat, and I'll try to relay these questions to the authors of the paper, and we can get some discussion and Q&A going. So this is from Wes Weimer. Some of these results, e.g. smaller edit spaces, are overrepresented in these searches. It seems like they agree with some of the directions you are pursuing. Does it seem that way to you, or am I misinterpreting this? Do you know, you're drawing a blank at this question?
Well, I would just say yes.
Oh, okay. That's a.
It wasn't
to
us.
Okay, that's fine. You can give a short answer if you want. I think Sandy asks, "Am I understanding correctly? The first result was showing that the delete operator was the least successful. That's very unusual, or that's just unusual."
So because the problem was program repair, it really depended on what was the actual repair to be made. If it was a deletion, then it was very effective because it was overrepresented. But as soon as the actual repair wasn't a deletion, then yeah, it was less effective. So it really depended on what was the actual repair to be made.
Okay. I actually will jump in with a question that I had for this work. Apologies, because just so everyone's aware, I don't actually get to see the presentation as it's being broadcast. So I watched this in advance and I can't remember exactly. But sometimes other operators act as if they are deletions effectively, right? Like replace operator can sometimes effectively be a deletion of code or equivalent to. So did you account for this in your research?
No, we just looked at the type of the edit.
Okay. Do you have any sort of intuition on this sort of direction, like equivalent mutations?
I think my only opinion is that even more overrepresent deletions, because yes, there are many ways that other edits can represent deletion. If you copy a variable declaration that is not used in your function, then it's essentially a deletion. Or yeah, if you replace it with anything which is not used, and it will, for example, be removed by the compiler, it is essentially a deletion. I'm not sure if it's really possible or a good idea to actually trying to take that into account. But yeah, if anything, that's another way that deletions are overrepresented in the search space.
Okay. So is there sort of like a future direction for this sort of research? Like, you're going to investigate this further? Because I find the topic very fascinating, but I have some like slight, because I don't know, I often find that deleting code is often the GI solution to a lot of things. And I would love there to be an answer that's not true. So have you got any like ideas, kind of future research on this?
On the direction of choosing the type of edit, there is a direction of using reinforcement learning. So for example, multi-arm bandits, if you repeatedly use deletion and it doesn't work, then you will try more the other type of edits. It can be also in terms of where in your program, in your software, you are applying modification or taking genetic material, rather than always using uniform sampling, then trying to use reinforcement learning to learn during the search that some portion of the source code are more stable or more safe to use than the others.
Okay, I like that direction personally. I think that's a really interesting way to take this research. So I think we've got one more question that's directed at you in the chat from Stephanie Forrest. How do you think the results would or would not change if you ran the same experiments on assembly code?
That's a good question. We will lose the second part of the experiments that try. Well, no. I'm not sure it will change anything. You will still have the issue of choosing the type of edit, and you will also have which type of assembly operator you're using. So in which you will have, well, each line of assembly for possible target, but each of these lines will be of different types. So you will still have to learn than some are more safe or more useful than the other to use.
But wouldn't you not have this problem of having to obey language rules? It would just compile. You wouldn't need to deal with compilation.
I'm not sure I catch that.
I imagine if you're working in assembly as opposed to a language, you're not as constrained by language rules, and you wouldn't have to worry about your code not compiling. Wouldn't the search space not be richer in that case?
Well, you still have to compile it to binary code if you are writing an assembly.
Well, I guess.
So you will still have to compile it. It still have a structure with the type of assembly operator you use and the arguments move that that value to that pointer. Or
yeah.
So
I'm arguing more like at that level you can do more stuff that's wrong, but will still run. You know what I mean? Which may not necessarily be a bad thing.
Yeah.
Yeah. Well, that's yeah. And someone's pointing out, well, you could still get syntax errors in assembly. True.
I guess you will have to learn everything anew because it's a different target. But once you learn the optimal setting, or at least the optimal start setting for assembly, then it might be much more efficient than uniform sampling.
Yeah, this is I think this is more of a comment, but I'll read it out anyway by Oliver Krauss. Deleting code would probably not be successful if you consider the fault submission, e.g. bugs that are caused by code not being there, missing if x equals null. Since that type of bug is only 25% of all bugs observed in code, this is a double odd, as the delete operator should be more successful outside of faults of omission. You're free to follow up on that if you want. I thought it was an interesting comment.
Well, our results were really that if the repair was a deletion, then having more deletion in your search page was more effective. And if your repair was not, then yeah, it was harder to overcome because you needed to actually generate the right repair rather than having to generate either the deletion or either a replacement that would act as a deletion, rather than yeah, considering the type of faults or yeah.
Cool.
Just kind of a comment. So maybe that's why replacement somehow would better than deletion, in that even if it can mask act as deletion, it preserves like some code to the next mutation. So it will, well, especially if you do multiple edits, it won't be as destructive, shall we say. I'm just hypothesizing why results are they are the way they are.
Mm.
And there are, two facets also. One is the type, and the other is location, which I feel like hasn't been looked at as much in the literature yet. So depending on location, you might skew the probabilities of applying the different types of mutations.
Yeah. I'm still amazed we're still talking about these delete, replace, and copy operations. They seem to keep coming back and being introduced. But it seems to be a lot of strength in them as well. I'm not exactly being critical, but yeah. You've got 2 minutes left, Americ. Do you want to expand anything on your research? I don't know exactly what the Clowder is. I don't think we can finish early in Clowder. I don't know.
No, I don't think so. My connection went down a second, so I didn't earn what Justina was saying. But if I could add something to the last question before my connection went down, it's the type of operator you use. So deletion, for example, might really be depending on whether or not you are dealing with functional or non-functional properties. So whether or not you are fixing bug or improving, I don't know, memory consumption or energy consumption. So that would also be depend on the type of problem you deal with. But,
yeah. I'll use this final minute I have to just do some workshop housekeeping. I'd like to remind everyone that there will be a Best Presentation Award at this workshop. We will send out the link. I believe it's going to be a link we're going to send out at the end of the last session, end of the last presentation for people to vote on Best Presentation. So please, obviously, attend the presentations, but keep an eye out for ones you think are done particularly well, and there will be an award for the best person, and that'll be done and we'll do the awards in the last session. Hopefully everyone can attend that time zone if your time zone works out. So 10 seconds left to go. So I'll see you all at the next talk, which is optimizing SQL queries using GI. Bye for now.